March 5, 1943. Aberdeen Proving Ground, Maryland. A German Tiger I tank, tactical number 712, arrives under United States Army Guard. Captured intact near Jadida, Tunisia, it becomes the first operational Tiger examined in the West. Colonel George B. Jarrett and his ordnance team note an immediate paradox. The tank's 88mm K-36L 56 gun penetrates any Allied tank at 1,500 meters. Yet its Maybach HL230 P45 engine burns 530 liters of fuel per 100 kilometers on roads, over 1,000 liters off-road. German-designed brilliance meets industrial impossibility. Engineers begin testing to answer a question that will expose the Wehrmacht's fatal weakness. How could Germany's strongest weapon be defeated not by enemy tanks, but by its own fuel tank? The Tiger could kill anything it faced, but it couldn't drive far enough to matter. The journey to this revelation began 2 months earlier in the desert hills of Tunisia, where American forces first encountered Germany's newest weapon in circumstances that would reshape their understanding of armored warfare. On February 14, 1943, elements of the 1st Armored Division peered through dust and haze as massive silhouettes appeared at ranges exceeding 1,200 meters. Rangefinders clicked. Commanders expected Panzer III or IV opposition based on intelligence briefings. What emerged was something entirely different. The first 75mm rounds from M3 Lee tanks impacted the approaching German armor and bounced away like pebbles skipped across water. Through binoculars, American tank commanders observed vehicles larger than any Panzer they'd encountered, mounting guns whose muzzle diameter suggested lethal capability far beyond standard German tank armament. At 1,500 meters, the Tigers opened fire. The first 88mm shell punched completely through an M3 Lee's frontal armor, detonating ammunition inside. The tank exploded. 2 more American tanks were destroyed within 90 seconds, all hit at ranges where American return fire proved completely ineffective. Lieutenant Colonel Louis V. Hightower, commanding the 1st Battalion, 1st Armored Regiment, watched as his tank companies encountered Schwer Panzerabteilung 501, demonstrating capabilities that made a mockery of American tank doctrine. The Tiger I weighed 57 tons, mounted 100mm frontal armor, and carried the feared 88mm anti-aircraft gun adapted for tank use. Against this combination, American 75mm guns were effectively useless beyond point-blank range. American intelligence had dismissed earlier reports of a new heavy Panzer as exaggerations. The reality at Kasserine Pass proved devastating and definitive. German after-action reports from Schwer Panzerabteilung 501 listed multiple Allied tanks knocked out with minimal hits received. United States Army reports noted shells bouncing like pebbles from Tiger armor at combat ranges. The tactical shock produced local German gains that threatened to split Allied forces in Tunisia. But within 72 hours of this first engagement, something unexpected appeared in German maintenance logs. Of 20 Tigers committed to the Kasserine offensive, 10 were non-operational within 3 days. Remarkably, none of these losses resulted from enemy fire. The causes listed told a different story: final drive failures, gearbox problems, track tensioning issues, and most critically, fuel exhaustion. A German quartermaster report dated February 17 noted that local fuel depots had diverted up to 60% of available gasoline to Tiger companies, leaving motorized infantry units critically short. Each Tiger consumed more than 500 liters per day under combat conditions. This requirement strained logistics systems already stretched by Allied air interdiction of supply convoys from Tunis. The Tiger dominated tactically, but collapsed operationally. Fuel convoys could not keep pace with the appetite of Germany's heaviest tanks. The Kasserine engagement revealed a fundamental paradox. Germany had engineered a weapon capable of destroying any Allied tank at 1,500 meters. But the weapon could not reach most battlefields under its own power without consuming fuel stocks that German logistics could not sustain. Tactical superiority meant nothing when the tactical weapon could not maneuver to where it was needed. In late January 1943, before the Kasserine battle began, this operational weakness had already produced intelligence gold for the Allies. Near Jeddah, Tunisia, Tiger 712 of Schwer Panzerabteilung 501 halted with dry fuel tanks. The crew, following standard Wehrmacht procedure, attempted to set demolition charges to destroy the vehicle and prevent capture, but Allied patrols advanced faster than expected. The German crew withdrew before completing demolition. American forces from the 2nd Battalion, 13th Armored Regiment, secured the intact Tiger. Serial plates were photographed. The vehicle was safeguarded under armed guard. Within days, arrangements were made to transport this priceless intelligence asset to the United States. A Tiger tank abandoned due to fuel exhaustion became the key to understanding German heavy armor capabilities and limitations. Field reports documented the circumstances precisely. Abandoned intact due to fuel starvation. Intelligence priority upgraded to exploitation. The first operational Tiger to reach United States hands became a laboratory for measuring the limits of German heavy armor. The captured Tiger arrived at Aberdeen Proving Ground in early March 1943, immediately becoming the focus of intensive examination. Colonel George B. Jarrett's Ordnance Division began complete tear-down analysis. Every component was measured, weighed, tested under various conditions. The turbo supercharger system, the interleaved road wheels, the Maybach engine, the transmission, all received systematic evaluation according to standard Aberdeen testing procedures. Jarrett's team removed armor plates and recorded thickness, weight, and manufacturing tolerances with precision instruments. They measured the 88mm gun's recoil system, tested the turret traverse speeds, examined the Bosch electrical systems. Translators worked through captured German technical manuals, cross-referencing specifications with observed reality. The physical inspection revealed impressive German engineering throughout. Surface finishes were consistently smooth. Components showed evidence of precision manufacturing to tight tolerances. Materials appeared to be high quality, with no obvious substitutions forced by resource limitations. But the road tests revealed something troubling. Aberdeen test drivers documented fuel consumption of approximately 530 liters per 100 kilometers on roads. Off-road consumption roughly doubled. The Maybach HL230 P45 engine, rated at 650 horsepower, delivered a power-to-weight ratio of approximately 11 horsepower per ton when moving 57 tons of tank. This compared unfavorably to American medium tanks like the M4 Sherman, which achieved better power-to-weight ratios despite smaller engines by weighing significantly less. The fuel consumption data reframed the entire threat assessment. Initial Allied concerns had focused on the Tiger's armor and firepower. These concerns were entirely justified. The 88mm gun could penetrate any Allied tank in service. The armor could resist virtually all Allied anti-tank weapons from the front. But Aberdeen's testing revealed that these capabilities came at a cost that German logistics could not sustainably support. Jarrett's preliminary reports circulated among Allied intelligence services with classification markings indicating their importance. The documents noted that Tiger's superiority was conditional on short, well-supplied operations. Fuel limits, not armor thickness, defined Tiger employment possibilities. The operational range figures were devastating for German planning. Approximately 120 miles on roads under ideal conditions, perhaps 30 miles under combat conditions, with acceleration, maneuvering, and idling. These numbers meant that Tigers could not maneuver independently beyond one day's operations without forward fuel caches. Strategic mobility was essentially zero. Tigers moved by rail to combat zones, fought brief engagements, then withdrew to rail loading points for repositioning. This pattern repeated across every theater where Tigers saw combat. The tactical weapon was operationally immobile. Aberdeen circulated initial secret notes emphasizing that fuel consumption, not armor protection, defined the real Tiger threat. Allied commanders adjusted their tactical thinking accordingly. The Tiger remained dangerous in direct combat, but could be defeated operationally by avoiding engagement until fuel constraints forced German withdrawal or immobilization. While Aberdeen analyzed the captured Tiger, German factories continued producing these fuel-hungry weapons. The Henschel works in Kassel and Maybach facilities in Friedrichshafen operated production lines that assembled Tigers despite growing evidence that the vehicles consumed resources out of proportion to their battlefield impact. Each Tiger absorbed materials and man-hours equivalent to multiple Panzer IVs, while multiplying the fuel burden per unit of combat effect. Factory floor scenes at Henschel showed assembly jigs and engine test benches, where Maybach HL230 P45 power plants underwent acceptance testing. Tachometers climbed as engines were broken in and certified. Each engine represented sophisticated engineering. The 14-cylinder design displaced 23 liters and incorporated advanced features including fuel injection and dual ignition. But the engine was designed for lighter platforms and struggled under the Tiger's mass. Henschel engineer Erwin Aders supervised production quality control and documented the compromises forced by military requirements. The HL230 engine was designed to power vehicles in the 40 to 45-ton range. Installing it in a 57-ton chassis meant accepting reduced engine life expectancy measured in hundreds of kilometers under combat load. This was not oversight, but calculated risk. Germany needed heavy tanks immediately and could not wait for development of a new engine specifically designed for such massive vehicles. Internal Henschel memoranda acknowledged that reliability trade-offs had been accepted to meet output quotas. Field units inherited high-maintenance platforms, with chronic fuel consumption problems built into the basic design, but strategic circumstances left Germany with few alternatives. The Tiger program had begun in 1941, when German armor dominated European battlefields. By 1943, when Tigers entered combat in meaningful numbers, German forces faced increasingly capable Soviet and Allied armor requiring heavy tanks to maintain any tactical advantage. Each Tiger absorbed approximately 8,000 kilograms of specialized steel in its construction. Multiple subcontractors provided precision components. Final assembly required approximately 300,000 man-hours. For comparison, a Panzer IV required approximately 100,000 man-hours. Germany could build 3 Panzer IVs in the time required to build 1 Tiger. The fuel burden multiplied proportionally. 1 Tiger company consumed fuel equivalent to 3 Panzer IV companies while providing combat power that did not scale proportionally. German military planning in 1942 and 1943 consistently underestimated the operational costs of fielding heavy armor. OKH planners projected that Tiger battalions would decisively influence combat through their tactical superiority. These projections assumed adequate logistic support. Reality delivered fuel shortages, maintenance crises, and operational immobility that undermined tactical advantages. By June 1943, German fuel allocation documents revealed crisis-level shortages. The Oberkommando des Heeres fuel section in Berlin compiled monthly requirement estimates, showing that heavy panzer battalions required approximately 900,000 liters monthly. Actual deliveries dropped toward 400,000 liters, as Allied bombing disrupted refineries and Soviet advances threatened Romanian oil fields. A staff officer's desk piled with allocation tables and rail schedules documented the impossible arithmetic. Planned requirements exceeded delivery capacity by more than 50%. OKH quartermaster officers and Army Group staff compiled fuel requests that could not be fulfilled. Signals officers noted ultra-suspected leaks indicating that Allied intelligence was tracking German fuel shortages and exploiting this vulnerability. Rail throughput limits, truck availability constraints involving 3-ton Opel Blitz vehicles, Soviet partisan disruption of supply lines, and Allied air interdiction of depots combined to create cascading logistics failure. Orders limiting Tiger training miles began appearing in unit files. Directives instructed commanders to move Tigers by rail whenever possible to conserve fuel and reduce transmission wear. Training hours shrank drastically. Units met battle under-practiced, with untested repairs and minimal maneuver reserve. German tank crews received excellent tactical instruction, but inadequate vehicle familiarization time due to fuel scarcity. British intelligence analysts at Bletchley Park noted German fuel distress through decoded communications. Intelligence summaries concluded that heavy tank units cannot maneuver independently beyond one day's operations without forward fuel caches. This assessment, based on signals intelligence and confirmed by captured documents, shaped Allied operational planning. German Tigers could be defeated by avoiding direct engagement and forcing them to maneuver until fuel exhaustion immobilized them. The fuel arithmetic shaped every aspect of Tiger operations from 1943 forward. While Allied planners developed tactics and weapons to counter the Tiger, they also recognized that time worked against German heavy armor. Each day of operations consumed irreplaceable fuel stocks. Each kilometer driven depleted reserves that German logistics increasingly could not replenish. The Tiger's greatest weakness was not armor vulnerability, but operational immobility caused by unsustainable fuel consumption. Allied forces internalized lessons from the captured Tiger and adjusted doctrine accordingly. Throughout mid-1943, American and British armor officers met at facilities, including Fort Knox, Kentucky, and various locations in Washington, examining Aberdeen data packets and formulating responses. The Ordnance Board conference tables saw detailed discussions of how to counter German heavy armor without attempting to match it directly. Lieutenant Colonel representatives from the United States Armored Force Board, British liaison officers, and logistics planners concluded that matching the Tiger's armor and firepower would be counterproductive. American industrial capacity could produce reliable medium tanks in quantities that overwhelmed German heavy armor through numbers and operational tempo. The M4 Sherman would never match the Tiger in direct combat. But Sherman reliability metrics and maintenance simplicity gave American armor critical operational advantages. Memoranda circulated, emphasizing that a tank that cannot reach battle is no weapon at all. Range and readiness figures favored Allied fleets decisively. The M4 Sherman could travel approximately 150 miles on a tank of fuel under combat conditions, 50% further than the Tiger. Sherman maintenance requirements averaged significantly fewer man-hours per operating hour. Spare parts availability through Allied logistics chains exceeded German capacity by wide margins. The M26 Pershing program, initiated to provide American forces with heavier armor and more powerful guns, incorporated lessons from Tiger analysis. But development timelines meant the Pershing would not reach combat units until early 1945. Meanwhile, American doctrine emphasized mobility, reliability, and combined arms integration rather than attempting to match German heavy tanks in armor protection or gunpowder. Procurement decisions reflected this philosophy. The United States produced approximately 49,000 M4 Sherman tanks during the war, compared to approximately 1,347 Tigers produced by Germany. This production ratio of roughly 36-1 meant that even with Tigers achieving favorable kill ratios in individual engagements, German forces would be overwhelmed by Allied numerical superiority combined with better logistics and operational sustainability. British forces operating in North Africa and later in Europe faced similar challenges against German heavy armor. Their response paralleled American thinking, but added one crucial element: the 17-pounder anti-tank gun. This weapon, mounted in modified Sherman tanks called Fireflies, provided British units with long-range anti-Tiger capability that American 75mm guns lacked. But even British planners recognized that the real answer to the Tiger was not better guns but operational warfare that exploited German fuel vulnerabilities. The fuel logistics targeted by Allied air and ground interdiction represented recognition that German armor depended on continuous supply. Breaking supply lines had more strategic impact than destroying tanks in combat. Every fuel convoy attacked, every depot bombed, every rail junction interdicted reduced German operational mobility and forced Tigers into defensive positions where their advantages diminished. The Eastern Front provided additional evidence of fuel consumption crippling Tiger operations. From October through December 1943, Schwer Panzerabteilung 502 and 503 operated in the Neville-Leningrad sectors facing Soviet forces. German operational reports documented that paper strength showing heavy companies with 40 to 50 Tigers rarely translated into operational readiness, exceeding half that number. Snow gathered in the interleaved wheels, requiring hours of maintenance before vehicles could move. Crews heated oil pans with braziers to reduce viscosity in temperatures dropping to -30 degrees Celsius. Railheads offloaded Tigers at night to avoid Soviet air attack. The entire operational pattern revealed fundamental constraints. Tigers arrived at the front by rail, fought brief engagements from prepared positions, then returned to railheads for repositioning because they could not maneuver cross-country without consuming fuel stocks that could not be replenished. Soviet intelligence summaries noted this pattern and adjusted tactics accordingly. Red Army doctrine emphasized fixing German heavy armor in place while mobile forces maneuvered around static defensive positions. Soviet tank formations avoided direct engagement with Tigers when possible, recognizing that German fuel shortages would immobilize heavy armor within days, regardless of combat outcomes. Winter operations on the Eastern Front multiplied fuel consumption problems. Viscosity increased in cold temperatures, requiring more power to overcome resistance. Rolling resistance doubled as snow accumulated and interleaved wheels clogged with ice. Track and wheel servicing consumed maintenance hours that reduced availability. Unit reports listed causes of non-readiness systematically: fuel shortage, gearbox failures, track and wheel servicing delays, engine problems exacerbated by cold. German commanders on the Eastern Front filed reports noting that short tactical thrusts followed by immobilization had become standard Tiger employment patterns. Soviet counterattacks exploited stalled heavy units that lacked fuel to reposition. By year's end, 1943, Germany had built hundreds of Tigers, yet rarely fielded more than 300 operational simultaneously across all theaters. Production continued, but operational effectiveness remained constrained by fuel logistics and maintenance requirements that German infrastructure could not sustain. The Battle of Normandy in June and July 1944 demonstrated fuel constraints in Western Europe. Allied air superiority complicated German logistics catastrophically. Refueling points established under hedgerow cover offered minimal protection from fighter-bomber patrols. Tank columns paused as P-47 Thunderbolts and Hawker Typhoons prowled overhead, attacking fuel convoys before they could reach forward units. German commanders anticipated decisive counterstrokes by Tiger units against the Allied beachhead. OKW planning documents called for concentrated armor attacks that would split Allied forces and destroy the invasion before it established irreversible momentum. These plans assumed Tigers would have fuel to maneuver. Reality delivered something different. Allied air attacks and fuel scarcity limited daily movement to short bounds from covered positions. Schwer Panzerabteilung 503 officers documented readiness levels near 35% throughout the Normandy fighting. Several Tigers were lost while stationary, during refueling or repair halts when Allied fighter bombers struck. The critical vulnerability was logistical exposure. Armor integrity became irrelevant when fuel trucks were destroyed before reaching tanks that needed refueling. Allied air reconnaissance photographs from July 1944 show intact Tigers positioned beside burned-out fuel vehicles. Mobility was killed without penetrating armor. The tactical weapon that dominated direct engagements proved helpless when its fuel supply was interdicted. German doctrine had not adequately prepared for operations under complete enemy air superiority. Tigers required fuel convoys to maneuver. Fuel convoys required road networks. Road networks under Allied air attack became death traps. The Conflans sector fighting illustrated this pattern repeatedly. German tank commanders positioned Tigers in hull-down defensive positions to minimize exposure while conserving fuel. These static deployments allowed Tigers to extract heavy casualties from attacking Allied armor, but surrendered strategic initiative. Allied forces could choose when and where to attack, while German forces remained tied to defensive positions by fuel scarcity. Jabos fighter bombers in German military slang attacking road columns had disproportionate strategic impact. Destroying a fuel bowser prevented a Tiger from maneuvering for days. Destroying several bowsers immobilized an entire company. Allied air commanders recognized this leverage and prioritized fuel convoy interdiction. Bridge weight limits complicated matters further by diverting Tigers onto roads where they became easier targets for air attack. By late July 1944, German after-action reports noted that several Tigers had been lost abandoned while stationary, rather than destroyed in combat. Crews withdrew on foot after their vehicles ran dry with no fuel resupply available. These losses did not appear in combat statistics as enemy kills, but represented attrition nonetheless. The Tiger's operational range became its decisive limitation. Crews could not fight without fuel, regardless of their armor, thickness, or gunpowder. The Ardennes offensive in December 1944 provided the most dramatic demonstration of fuel constraints, defeating German heavy armor. Adolf Hitler personally ordered this last major German offensive in the West, gambling Germany's remaining strategic reserves on a surprise attack through the Ardennes forest toward Antwerp. The operational plan explicitly depended on capturing Allied fuel dumps to sustain the offensive beyond its initial phase. Kampfgruppe Piper, the spearhead formation, consisted of approximately 100 tanks and assault guns, including several dozen Tigers and King Tigers, advancing on the northern shoulder of the German attack. SS Obersturmbannführer Joachim Piper's staff officers marked map cases with fuel objectives, clearly identifying Allied depots that had to be captured to continue the advance. The operational design assumed German forces would seize intact American fuel stocks during the initial breakthrough. German planning documents acknowledged that the Ardennes offensive could not be sustained by Wehrmacht logistics alone. Supply convoys struggled to deliver sufficient fuel through snow-blocked mountain roads. The entire operational concept required fuel seizures from captured American depots. This dependency represented desperation rather than sound planning. No military operation should depend on capturing enemy supplies to continue, yet German strategic circumstances left few alternatives. The offensive began on December 16th, with German forces achieving complete tactical surprise. Initial advances penetrated American lines, captured territory, and caused panic in Allied rear areas. Weather conditions grounded Allied air forces for the first several days, temporarily neutralizing American air superiority. German armor advanced more rapidly than American commanders thought possible. For brief moments, the offensive appeared to validate Hitler's confidence in willpower and tactical skill overcoming material disadvantages. But the mathematics of fuel consumption could not be overcome by tactical success. Kampfgruppe Piper advanced approximately 90 kilometers in 4 days before fuel exhaustion forced a halt on December 20th. Allied demolition teams had destroyed fuel dumps ahead of the German advance. Engineers at Stavelot set fire to a major fuel depot containing over 2 million liters when German forces approached within 1,000 feet. Radio messages from Piper's command to higher headquarters requested fuel, not ammunition or reinforcements. The offensive's tempo collapsed before decisive contact was achieved. Individual Tiger companies reported fuel exhaustion, preventing further movement while their ammunition racks remained partially full. This reversal of normal combat logistics, fuel exhausted while ammunition remained, illustrated the fundamental flaw in Tiger operational employment. The vehicles carried devastating firepower, but could not position that firepower where it was needed without fuel that German logistics could not deliver. German commanders had designed the Ardennes offensive around operational assumptions that proved false. They assumed surprise would paralyze American response long enough to seize fuel dumps. They assumed winter weather would ground Allied aircraft long enough to move armor beyond air interdiction range. They assumed German tactical superiority would compensate for logistics weaknesses. All these assumptions collapsed when confronted with reality. American forces recovered from initial surprise faster than German planners anticipated. Combat engineers destroyed fuel stocks before German forces captured them. Weather cleared by late December, allowing Allied air forces to resume operations. American logistics brought reinforcements forward faster than German commanders thought possible. The offensive consumed Germany's last operational reserves of fuel, armor, and experienced troops for no strategic gain whatsoever. Post-war interrogations of German officers confirmed that fuel exhaustion, not enemy armor or infantry resistance, ultimately stopped the Ardennes offensive. Joachim Piper stated in Allied custody that his formation possessed combat power to continue attacking but lacked fuel to move. Tank commanders across the offensive reported similar circumstances. Their vehicles remained mechanically functional. Their crews remained ready to fight. But without fuel, the Tigers became immobile fortifications rather than maneuver weapons. The fuel dependency had been clear since Kasserine in February 1943. Aberdeen's testing in March 1943 quantified the consumption rates precisely. Allied intelligence tracked German fuel shortages continuously throughout 1944. Yet German strategic planning continued, designing operations around Tigers without adequately accounting for their fuel requirements. This represented either willful denial of logistics reality or complete absence of alternative options. Either explanation indicated Germany's strategic position had become untenable. By March and April 1945, as Allied forces advanced into Germany proper, Tigers were increasingly found abandoned intact due to fuel exhaustion. Crews destroyed weapons and radio equipment before withdrawing on foot, leaving tanks that had never suffered combat damage immobilized by empty fuel tanks. Henschel factory records seized by United States forces showed production totaling 1,347 Tigers, built from 1942 through 1944. Allocation records documented where vehicles had been distributed. Transport modes to front units typically involved rail movement. Operational availability documents told the final story. At Germany's surrender in May 1945, approximately 1,347 Tigers had been produced. Fewer than 250 remained operational. The remainder had been destroyed in combat, abandoned due to mechanical failure, or left immobile by fuel exhaustion. Average operational readiness across all Tiger units throughout the war stabilized near 35% compared to approximately 85% for American M4 Shermans. This readiness differential meant that even when Germany possessed Tigers on paper, actual battlefield availability was roughly one-third of nominal strength. Erwin Aders, the Henschel engineer who supervised much of Tiger production, stated in post-war Allied interrogation that we were not building for economy. We were building to survive the first hit. This design philosophy produced a tank with exceptional armor protection and devastating firepower. But economic efficiency and operational sustainability were sacrificed to achieve tactical superiority. The Tiger could survive hits that destroyed other tanks. It could destroy other tanks at ranges they could not reciprocate. These capabilities meant nothing when the vehicle could not reach battle because fuel was unavailable. Colonel George B. Jarrett reviewed post-war data at Aberdeen and compiled comprehensive assessments comparing German and Allied armor programs. His analysis incorporated combat reports, captured documents, interrogation transcripts, and technical evaluations. The conclusions appeared in classified summaries distributed through United States Army ordnance channels and shared with British intelligence services. Jarrett's final assessment stated that Tiger performance, negated by unsustainable logistical demand, represented the fundamental verdict on Germany's heavy tank program. The vehicle's tactical capabilities impressed Allied engineers and tankers throughout the war. Its operational limitations crippled German armored doctrine. The Tiger shaped future armor design not by imitation, but by cautionary example. Post-war tank development emphasized balanced protection, mobility, and maintainability, rather than maximizing single characteristics at the expense of operational effectiveness. American M26, Pershing tanks, and later M46, M47, M48, and eventually M60 designs all incorporated lessons from Tiger analysis. These vehicles provided improved armor protection and heavier guns than the M4 Sherman, while maintaining operational range, mechanical reliability, and maintenance simplicity that made them sustainable under campaign conditions. Soviet tank development followed similar principles, with T-44, T-54, and T-55 designs emphasizing operational mobility and mechanical durability alongside combat capability. British tank development, through the Centurion program, explicitly rejected the Tiger's design philosophy. Centurion designers prioritized mechanical reliability, fuel efficiency, and maintainability after studying German heavy tank failures. The resulting vehicle provided excellent armor protection and gun power, while maintaining operational range exceeding 400 kilometers, more than 3 times the Tiger's effective range. This represented conscious application of lessons learned from German logistics failures. German heavy tank designers had created weapons that dominated tactical engagements but collapsed under operational demands. The Tiger could defeat any Allied tank in direct combat, but could not maneuver to where direct combat occurred without consuming fuel that German logistics could not provide. This fundamental contradiction shaped the vehicle's legacy more than its impressive armor thickness or powerful gun. A historian analyzing production statistics in the late 1940s totaled columns documenting the mathematics of defeat. Germany produced 1,347 Tigers, compared to approximately 49,000 American Shermans and 84,000 Soviet T-34 Range comparisons showed Tigers managing approximately 120 miles on roads under ideal conditions compared to 150 miles for Shermans and approximately 250 miles for T-34. Combat range figures were even more disparate, with Tigers limited to roughly 30 miles under combat conditions. These numbers demonstrated that strategic outcomes turned on supply mathematics rather than tactical capability. Tons delivered, hours maintained, kilometers driven, these operational metrics determined victory more surely than armor, thickness, or gun power. The Tiger's defeat was not tactical, it was logistical. Its armor was impregnable, but its fuel tank was mortal. Germany trusted in singular weapons designed to dominate individual engagements. The Allies trusted in systems factories, fuel infrastructure, repair networks, logistics chains, proving which approach wins campaigns. The Tiger represented German engineering excellence applied to tactical problems without adequate consideration of operational and strategic constraints. Allied armor programs represented industrial systems thinking applied to warfare, creating sustainable combat power that could be maintained across years of campaigning. If you value fact-based military history grounded in archival evidence and rigorous analysis of how logistics shapes warfare outcomes, consider supporting content that examines these often overlooked dimensions of conflict. The Tiger tank story ultimately demonstrates that modern warfare is won not by individual weapon superiority, but by logistical sustainability and operational effectiveness. The vehicle that could kill anything it faced, but could only travel 30 miles under combat conditions before running dry, became a metaphor for Germany's broader strategic failure. Engineering brilliance and tactical excellence could not overcome fundamental resource limitations and logistics weaknesses. The Tiger dominated battlefields it could reach, but could not reach enough battlefields to influence strategic outcomes. Its legacy teaches that in industrial warfare, operational mobility matters more than tactical invincibility, and fuel consumption determines battlefield presence more surely than armor thickness. The captured Tiger 712, that arrived at Aberdeen Proving Ground in March 1943, revealed this truth through systematic testing and careful analysis. American engineers measured fuel consumption rates that German logistics could not sustain. Allied commanders adjusted their operational planning accordingly, avoiding direct engagement when possible, and exploiting German fuel constraints to achieve operational objectives. The Tiger's secrets, exposed through one captured vehicle, helped shape Allied victory not by providing designs to copy, but by revealing weaknesses to exploit. In the arithmetic of modern war, the side that can keep its tanks moving, supplied, and maintained will defeat the side that builds better tanks but cannot fuel them. Aberdeen's testing proved this equation conclusively, and subsequent combat validated the conclusion across every theater of World War II.